So to introduce the goals and workflow involved with posterior prediction, we're going to use a non-phylogenetic example, as I mentioned earlier. And so here we're going to use a hypothetical data set of trait values that we've sampled from a population. And as it turns out, this population is sexually dimorphic, with males and females having both different mean trait values and different variances in those trait values around each of those means. Now, for the purposes of our tutorial, we are going to say or assume that we don't yet realize that sexual dimorphism exists in our population. This might seem sort of ridiculous because we can simply plot these trait values in a really simple visual way like I have here and recognize that, that there are different means, that we have a bimodal distribution across the entire population. But for many models, doing such a visual comparison isn't nearly as straightforward. And so by illustrating posterior prediction in this way where we can compare it visually to our data, we can gain a sense for how these more formal quantitative checks that we're doing match our visual intuition. So if you're interested, we won't need to deal with these data directly, but if you're interested, you can go to the data files and script section, and under data files, you can find data.txt, and that contains the trait values for 100 hypothetical individuals that we've sampled from this population. And so those trait values are represented in this smooth kernel density plot shown here in figure 1.